the explosive rate of data production is changing science in fundamental ways. The vast amounts of scientific data being produced today can no longer be effectively interpreted, communicated and shared through papers. Without proper stewardship of data, potential scientific progress is more and more impeded by fragmented patches of information that cannot talk to each other. The tremendous growth in information is therefore not effectively translating into an increase in knowledge. To harness the power of big and complex data, people and machines need to work together. To make this happen, the revolution in data production needs a revolution in data stewardship. Good data stewardship follows fair guidelines and will enable an internet of data and services, helping data and algorithms to find each other, talk to each other, and remain available for reuse. The European Open Science Cloud is a European initiative to support data reuse, accelerating open science and innovation.
So at the LUMC, we have a program. We're putting all sorts of finances from all sorts of sources together to start doing this. And in the middle, you have the fair data stewards that are working in our department, basically close to us. And we're doing pilot projects, for instance, with LUMC librarians and data managers on one hand, but also collaborating with the ICT department here at the LUMC. And the data stewards also interact with the FAIR software engineers to co-develop and feed the feedback on the services. So this is a setup that we have started at the LUMC. In the rare disease domain, you would have something similar, where you would have but it's more rare disease oriented, obviously, more international. There's also a central group of FAIR data experts working together with rare disease data stewards out in the domain, and registry software providers on the other hand, and again working with the FAIR software engineers on getting the proper tooling out. So that brings me to the services, the main topic of this webinar, because these people, these FAIR data stewards, they will need some tooling to work with and help other people with. And in this, so we list here, so in four branches, so create FAIR data, publishing FAIR data, finding FAIR data, and annotating FAIR data or knowledge graphs. And in this webinar, we'll mainly focus on these three: create, publish, and find. And also a note. So this is a implementation of FAIR data principles. Obviously, we try to make them as good as possible, but they're not necessarily, we will never claim that they are the implementation of FAIR data. Also, you'll see throughout this webinar this sort of general verification workflow that we use both in BYODs and FAIR data projects. And I will come back to this workflow now and again. So it starts with the questions across multiple sources. That is our motivator for doing all this. Retrieving pre-FAIR data and analyzing the data and finding the right semantic models to represent the data and converting it, making it linkable, assigning license and adding metadata, and ultimately deploying the FAIR data resource, combining it with more linkable data so that we can perform the queries to answer the questions. That's the workflow. And for several steps of these workflows, the tools and the services that we talk about apply. So for the making it linkable, there's the Open Refined Verifier that basically Rajan will introduce. There's the FAIR data point and a metadata editor. And for the demonstration, there's a FAIR data cache and the demonstrator itself. And the demo will actually do the other way around in the talk. So a central part is the FAIR data point, which by itself addresses the find and the access part of the FAIR principles. And it's I think, elegantly built in a sort of layered approach that you can see in this picture. And here in this other slide with a little bit more detail on the vocabularies that are being used. So at the top there's the FAIR data point itself. It has a description, machine readable and human readable. It contains catalogs. These catalogs contain one or more data sets, and the data sets can be available in one or more distributions, so different forms of the data. It could be a CSV file or a fully fledged interoperable RDF file. And finally, there's the accessor, which is kind of the protocol of how to actually get to the data. And you can also have different options there. And for this, there's a vocabulary used, the data catalog vocabulary, and the registry of research data repositories. So the metadata is also used for getting access, which I think is very helpful. So in part 1, we focus on that. In part 2 of the webinar, we'll do the last part is making the data interoperable itself, the final 2 letters of FAIR. So in part 1, the first video, Rajram will show, so we'll go backwards, as I said, in the workflow. We'll first show the demonstrate and the FAIR data points. So Rajram will show how we use that to answer questions across data resources. And we'll use data from the rare disease case. In this case, it is based on real data, but we made mock data out of it to avoid any privacy problems. He shows the FAIR data point that operates under the hood, searching and adding a FAIR data point, and then he shows how to get more answers by actually adding another FAIR data point.
In this video, I would like to demonstrate a web application which we built on top of FAIR data point. This is a web application which we built for rare disease researchers. This application combines data from different biobanks and patient registry and answer some of the commonly asked questions in rare disease world. Here you see the architecture of this web application. On the top you see a web client which is connected to a backend. In our case, is connected to a linked data store. The content of this linked data stores are coming from different biobank and patient registry FAIR data point. This is a web application. Here in the top you see a list of predefined queries. When you click one of this query, you get a form to fill in. So in the query which I clicked, I'm looking for number of biosample from a donor with particular phenotype. So the query requires phenotype as an input. So if you select a different query, then you get a different form to fill in. I already preloaded this demonstrator with some data. So I would like to answer this query, where I would like to get a number of biosamples from a donor with particular phenotype. So I'm going to select a white mouth as a phenotype, and when I click process, I get a result table here where my demonstrator suggests it finds 6 biosamples from this particular biobank. By the way, all this blue text are clickable links. So if I click the biobank link, I get some information about a biobank, which is a tool in a rare disease world which collect information about different biobanks and patient registries related to rare diseases. So when I click the phenotype link, I get a redirect URL which points me to white mouth concept from human phenotype ontology, where you get more information about white mouth concept. And this particular ontology also has a nice hierarchy. Let's see what happened if I select one of this upper concept as an input for my query. When I do it, I get a result table where you see a number of different phenotypes related to head and neck or reporter. So I see wide mouth is reporter, also see abnormality of teeth as reporter in my result. And here you also see you get results only related to one particular disease. So in order to look for data sets that are published in a FAIR data point, you can use this tool called FAIR data search, which simply indexes metadata from different FAIR data points and the user can search for like a data sets that they are interested in. So I'm interested in like ring 14 database. So when I search, when I enter it in a search box, I get a result. So in this particular fair data point, the ring 14 clinical data set is described. So this is the landing page of that particular fair data point. So where you get like some metadata information about that particular fair data point, and this fair data point contains 2 catalogs. When I click one of those catalog, I get like more information about that catalog. So I get like you can see it like it's a catalog about disease registry, and this particular catalog contain like 2 data sets. When I click one of those data set, and I get like more information about that data set. So in this case, like I get information about like a ring 14 clinical database, and this particular data set is distributed in 2 formats, as a HTML page and like as a turtle format. When I click one of that, then I get like more information about that particular distribution, and this is a turtle distribution, and we can download like the content of this database via this link. So when I provide like this as a input to demonstrator, so I'm basically asking demonstrator to index like all the metadata information from this particular fair data point, and also if some of the data sets is distributed in a turtle format, I'm also instructing my demonstrator to index those turtle files too. So I provided a link, I gave a name for this particular fair data point, and when I hit like a cache button, all the metadata information are indexed now. So when I go back and execute like the first query again, so when I select like abnormality of head and neck as an input and process it, now I get like more results, and now I get like results which are reported for like ring 14 disease as well.
Just to show you that the tooling, the services are really very generic middleware. This is the same demonstrator, but then on plant fair data points. So just a snapshot to show that principle. So we've seen the fair data point, and we've done the find and the access part, and you've seen that we've used a vocabulary to structure that, so to say. And you've seen Rajam point at some identifiers for a theme part, which is where we make it extra findable by globally defined terms, like order ontology terms or by schema. So this part is then, so again, this is a summary of what Rajam showed, answering questions across data resources, the fair data points that we're working under the hood, searching and adding a fair data point, and getting more answers then eventually with the added fair data points. So the next, we'll go to the actual making the data interoperable. So that's the other part of the workflow. And in the next video, where we're going to give Rajam that challenge again, we will show his semantic model for a specific application. So we're not going into the applications very deeply, but that's just take my word for it. Then he will show finding ontological identifiers, the URIs, for one particular relation. We're not showing it for all of them. And then adding this relation to the data in the verifier tool, exporting the linkable data and pushing it directly to a fair data point, and adding metadata to the fair data point by the metadata editor.
Before I start with the verification process, I like to draw your attention to the model which I'm going to use in the verification process. So you start your verification process by clicking on like create project button. So I'm going to use like a dummy dataset from ring 14 patient registry. I select the file and click OK and click next. This is a default view of verifier. So when I go back to my model now, so this is a triple that I would like to initialize first. So I'm going to create like a URL for each patient, and I'm going to assign like a type definition for that URL. So according to my model, the type definition is coming from SNOMED-CT ontology. So you can use like existing ontology repositories like bioportal to search for ontological URL. So I'm going to search for like patient in bioportal, and bioportal will suggest me like a list of ontology which contain patient concept. But according to my model, I'm supposed to use like a patient URL from SNOMED-CT. So this is a type definition URL that I'm going to use for my triple. So when I go back to Verifier, so in order to create like triples from your dataset, you can use like RDF plugin in the Verifier. So click on the RDF button, select like edit semantic model button. Now what you see here is like a subject configuration option, and you can add property to the subject. You can configure your subject URL by clicking on row index button here. I want to use URL with the patient ID as a suffix of my URL. So I'm going to choose like patient ID, and this is of type URL. Verify your final URL by clicking on preview/edit button. So this is how my final URL looks like. It starts with the prefix mydomain.com/resource and ends with suffix, which is like a patient ID. Click OK and click Save. So here, like the RDF preview session, you can see preview of the RDF what you created. I just initiated like a subject URL. I didn't add like any properties to the subject URL. So I would like to add property called like RDF type. You can do it by clicking on like add property button. Then you get like a property configuration options where I'm going to search for like a RDF type. I have to assign like an object for this predicate. In my case, I'm going to use this URL. So I copy this URL, go back to Verifier, and I say like I'm going to provide like a constant value, because this URL is going to stay for all the patient ID in my dataset. So I'm going to paste the SNOMED-CT patient URL, and I'm going to say this is of type URL, and click OK to close this button and save your configuration. And you can preview it by clicking on RDF Preview section. Now you can see I initiated like a subject URL which is of type SNOMED-CT patient URL. And I'm going to repeat the triple initialization step for all the triples described in this picture. And this is how edit RDF schema alignment window looks like if you initialize all the triples according to this model description.
So just to recap what happens, just the first three steps. So you've seen the semantic model that Rajaram used, and that's an application model built from different ontologies. You find it was looking for ontological identifiers in bioportal, and at that moderation, and then we skipped the part where you did that for the whole model and for all the data that was in the data set. And that's basically where we are now. So we have everything set up to do the actual conversion. So in the workflow, you see now we're ready to do the conversion and create yet another fair data point.
So once you finish with editing the RDF schema, post this RDF file directly to fair data point. So you can do it by clicking on like export button and select post to fair data point option. So here like you'll be asked to provide like a fair data point URL. For this demonstration, I'm going to post the file to this particular fair data point. So this particular fair data point contains like one catalog. So I'm going to post it to this particular catalog. So here like you provide like a base URL of your fair data point and select apply, and you get to choose like catalog from this fair data point. In this case, I'm going to post it to test catalog, I'm going to add a data set. Let's name it as a test data set. And this is version 1. And I need to provide like a publisher URL. So in this case, I'm the publisher, so I'm going to use my ArcID URL. And add publisher name. I'm going to add my name. I'm just going to make up some theme here. Click save. Now I'm going to add like some metadata information about this particular distribution, which is pushed to Virtuoso. So again, I'm going to name it as a test distribution, open license, and this version 1.4, and click save. When I click OK, the metadata and data will be pushed to fair data point. So I can verify it by going back to the fair data point, and I'm going to look into the catalog. So this catalog now contains like one data set. When you click on the dataset link, you get like metadata information about the dataset, which we posted using Verifier. And this particular dataset contains one distribution, which points to a Virtuoso instance to which like a fair data point is connected to. And this is our RDF file that we created in the verification process.
So again, what you see is the fair data point in action, and now the fair data is I would say complete, at least for how we implement it. So the findable and accessible we've done in the first part, that was the fair data point itself, and now we've also made the data itself interoperable and reusable and machine readable by semantic web standards and recommended or recommendable ontologies. And we've also, and we'd like to push that idea and also develop that further to stimulate convergence. We've shared it on fairsharing.org. The same models that they've used for real applications, we can see the same ontologies being used. In conclusion, we've seen the create, publish, and find services. They're definitely middleware applications. I think you could all see that what we've shown here today was for data stewards. You wouldn't push that directly to end users, perhaps the demonstrator, but the services are for data stewards and other technically skilled people. So the verifier, the second part, they're actually very useful for data linkage training workshop and BYODs. And we also see it as a prototyping verification process tool. But we also have some other ideas of how verification can take place in real projects. And that relates to what I could call a fifth part of the services that we're creating, the adopt part. Because we'd like not only the services, but also the concept behind it to be adopted. And I've made this slide for that. So in the creating part, you can have many of the tools that several of you on this call are also working on, like mapping services, RichDB and Molgenis as a mapping service, the EBI tools, but also in our rare disease domain, registry software can be an element in the creating fair data. For publishing fair data points, we are working with and actually people have done it independently of us as well, to create these fair data points. So I've listed here a few that have been created or that in the process of being created. That's actually something that in many cases we see that tools for finding already exist. So we'd like them to take up the fair data point. We're working with Molgenis on that, and ID cards, which is used in the rare disease domain to find registries and biobanks. And again, I didn't go deeply into that. It's also a little bit more experimental, but we can see that being used in the Euretus knowledge graph is a commercial tool. We want to use it for our own fair metadata, and knowledge.bio is a tool created at Scripps in the US that might be one of the adopters there as well. So the other part I just wanted to highlight is the adoption in the disease domain, and this could replace this whole part of the workflow, the verification part, by registry software in this case. And this is a project that is led by David van Enkelvoort, technical lead, on working with registry software providers to put this part of the workflow into their tools. And that's currently an ongoing project as part of the rare disease data linkage plan that we are running. So some pointers for developers. So here there's a wiki and there's a GitHub link, and it's not ready for release yet, but I think this year we'll have the release of the architecture for software providers. And we'll provide that link as well. And finally, just some reference to other types of services that are in the making. I showed it in the very beginning. First, as a service, fair data stewards that we have and that we're also training through our verification project. Training materials, tutorials, lectures, webinars, often coming out of the work we do for Bring Your Own Data workshops. We also have a course, a week-long course that Katie Wolstencroft and I coordinate, and that will take place in January again. So you can pre-register or forward it to other people. And we also target managers, data managers, with their project blueprints, all with budget and everything. And there's organizational support that we can give, for instance, for BYODs, but also these GoFair networks that can help organize communities to work on verification of their domain. And at the end of my story, there's a lot of people to thank. They're on this slide. I'm not going to everybody in detail, but there's and especially from me, I would like to applaud the team that Luis is leading, the Fair Data software engineers. I think they're producing very elegant services that can be put into different tools.